iOS calendar.
Yep.
So the problem, and the problem with that is like these notions that I just mentioned, holding state, like trying to, you're essentially creating what programmers call a state machine, which is this thing that holds on to temporary values and kind of steps with you through that process, because it's remembering stuff for you. It remembers the last number.
Is it kind of like volatile tables a little?
Like what?
Volatile tables? Like it holds it for a temporary.
Yes.
Kind of like that same concept.
Yeah. So like if you're doing 1 plus 1, or let's do something better, like 2 plus 3. You have to type in 2, and it has to remember the number 2 and show it to you. And you hit plus. And now it has to remember that you're adding.
Right.
Then
Got
you
it.
hit 3, and then it has to remember 2 plus and 3, and then equals, and then it combines all of those together. So you're feeding it not only raw data but also instructions. So
Okay.
a lot of those instructions. So you know, sometimes it works. Well, sometimes it's clear how to do it, and sometimes you can drink it weird. So I think that we're either going to do that, or next class we're going to set you up for it.
Okay.
Okay.
Sounds good. Thanks.
Stuff in the class is about to get real, and there's some tension in the air. There's like stuff starting to get confusing. So on top of a little bit of Doge here, like I think Daniel's going to try to arrange a night out with drinks with the previous classes, previous students who completed the previous classes, so you can get reassurances from them that you're going to make it. Right. That you have all the tools that you need to actually start writing. Today we're actually going to write a couple of apps using table views. And some of the patterns that are common to all iOS apps. So we're actually going to start talking about app frameworks, app organizations, and the code design, and the code that drives those organizations.
My new neighbor has a Shiba.
Oh, really? Is he rescue or?
I don't know. I just see it from afar. It tries to jump over the terrace into the courtyard and runs all around the place. It's not very well behaved, but it's really cute. Yeah.
Shibas, you have to.
Yeah, you gotta watch
them.
There's a Shiba like zoo over in National Square Park.
Oh, yeah.
I saw like 20 of them the other day all running around, and I was thinking,
Yeah. I ran into some owners of a Shiba in my old neighborhood once, and you end up knowing all the other Shiba owners. And one of them was named Zeus, and Zeus was this white cream Shiba owned by a former couple that owned Infirmary on 2nd Avenue bar. And I think it was them that told me that they went to one of these meetups with the Shibas. And Shibas generally don't get along with other Shibas when they grow older. So she said it was like, it was the worst. It was like the most antisocial meetup that they'd ever seen with dogs. They're all about to bite each other's heads off. Anyway, okay. So today, let's get rid of Doge there. Today we're going to talk about table views. Table views in depth. Now, we did a little bit of table view exercise before, at the end of last class. That was, I think I went a little too fast through that. And what I think we want to do today is try to step through that app, but in a different context. So a couple of the assessments that are coming up involve building a to-do app, a task list. And the value in the table view exercise we did last time was that you got familiar with this table view controller object. The table view controller is a convenience controller that puts a lot of stuff together for you. It's actually practice, very rarely used. So there's going over table views in the way we're going to do today exposes you to a couple of new concepts that are common to all iOS apps. This notion of a protocol and a notion of a design pattern, specifically a delegate design pattern. And I'm going to go over what those mean, what those are like, why they're useful. And we're actually going to build a task list here in class as quickly as we can. So I'm just going to set a little timer here for myself. Okay. Now, first, what I want to do is review arrays and dictionaries. So today you're going to learn what it means to meet a protocol. So this is a new concept with regards to object-oriented design. We're going to look at your first design pattern, the delegate pattern. We're going to use table views without a UI table view controller. That is, we're going to create a delegate for it, and we're going to do that by using protocols. If we get to customizing table view cells, then great. We're probably not going to do that for today. We're going to show you specifically an easier way and a more acceptable way of passing data from one scene to another, because it's not immediately obvious how to do that. And it's not something that Interface Builder gives you out of the box. You have to do it. You have to implement it yourself. Okay? So, review of data structures. So arrays are linearly arranged groups of values, typically of a single type. So here are some of the operations that we've done before. They're probably the most common data structure that you'll ever use. They are indexed by integers. They maintain their order. That is, when you add a series of integers to an array, that they will always stay in that order from beginning to end. And you can iterate over them using for loops. So arrays combined with for loops is actually a very powerful pattern. That's pretty much the power of computing that you have in your hands right there. Is being able to say, I have tons of data arranged in an array, and I'm able to use a for loop to write small amounts of code to operate on thousands and thousands, millions, or sometimes billions of data points. Dictionaries. Dictionaries are very similar to arrays, but instead of being indexed with integers, you actually define what type you're going to use to reference that data. So instead of indices and elements, as we have in arrays, we have what we call keys and values in dictionaries. So keys must be unique. They're the thing that you use to reference a value in the dictionary itself. So the analogy that we used before was like a literal word dictionary, like an English dictionary, where the keys are the actual words and the values are the definitions of those words. And in the dictionary we call that an entry, which is a word and a definition. In dictionary parlance, in Swift, we call it a key-value pair. So the key is the thing that's unique, that you use to reference. The value is the thing that you're trying to reference. So the example that we used before was a series of physical constants, physical and mathematical constants. And again, you can iterate over them with for loops using this particular syntax. One of the fundamental differences between arrays and dictionaries, one is arrays are ordered, and their bounds are very well defined, so they have a beginning and an end, and they have a particular number of elements that they have. And you have to add elements to them one at a time, either inside the array at the beginning or the end. Dictionaries, however, do not have that restriction, because the keys are values like strings. You can create a key value pair just by referencing a new key that the dictionary doesn't already have. So But what that means is the behaviors for referencing values that a dictionary or an array does not have are different. An array, when you give it an index that does not reference the acceptable range, or what we call the bounds of the array, which is 0 to the number of elements minus 1, the array will complain. A dictionary, however, when you reference a key that it does not have, it returns the value nil. So we have to use very peculiar and very peculiar syntax, this if-let syntax, in order to properly check for whether a value is nil or not coming out of an array. So, having said that, let's do a couple of examples and see just how much you all remember. So, Constantine, can you give me, how would I declare an array of doubles? Do you remember?
So,
Oh, get away.
I don't know what to call it.
It's a bracket.
That
Do you all
is
know what? Do you all know what
brackets.
the? Do you all know exactly what these are all? Parens.
Oh, that's
Parentheses. Brackets. Braces. Sometimes we'll call these sharps. Okay.
okay.
All right.
So between the brackets, I will put, or I will just put 2 brackets. Then it's open for later on to add elements.
Right. But what's the type of this array?
Right now,
Right now. Sean, what's the type of this array? Do we know the type of this array? Let's see it. Right. Not precisely. Megan, we want an array of doubles, so what's a way to turn this into an array of doubles?
Enter double
Okay.
between the bracket.
Sure. Like this.
Yeah.
Is that going to work? Oh, we have an error. Allison's missing.
It
Oh.
works with string. Why won't it work with double?
Is there something missing in my syntax here?
Yeah. So variable var
Var.
has to have ARR to know that it's an array.
Nope. Actually, that's just a name. So anything that comes right after the var keyword is up to us. We can choose whatever we want to put there. It's a variable like any other variable. And
Okay.
it'll hold values of the type array of double. So you understand what the type designation is. So typically a variable with a primitive type will hold a value of type double, a value of type string. Arrays are a more complex type. So just like we say an optional string, we can say array of double, array of string. So that's the type designation.
Would it have to have another equal after the bracket and then 2 more empty brackets? Or, yeah, 2.
Not at this point, because since we have an equal sign here, like there's typically only one equal sign ever in an assignment operation. So we can never actually put another equal sign here. So what does this, do you remember, does it show in your notes what the syntax is for declaring this as a, for finishing this call to numbers? Sorry. Sorry.
Oh, I was saying it's in the PDF. The PDF you were just showing it as you.
That's right.
Isn't it colon double?
Okay, so
Someone said it. Someone said it.
You need a colon for declaration after.
okay. So
Right after.
where does it go?
After the variable.
Okay. And then what
Double.
happens here?
Double will stay in bracket.
Oh,
Okay. Like this?
and then
Okay.
the equal, right?
There's no
Yeah.
difference, is it?
And now what? Am I done?
The brackets.
2 brackets. Okay, great. So there's
That's
one
what
way.
that's what I meant before.
Okay. Yeah. We have to be complete when we talk about syntax because Swift is extremely strict. So 90% there. We just needed that colon to replace the other equal sign. Okay, great. So let's add some doubles to this array. So Raj, give me a double that I can put in this array. How do I do it?
Oh, in that.
Where else? Add a double to this array. Give me the syntax to add a double to this array.
Var, just pick a double.
Just pick a double. Pick a number out of the air.
22.
22. All right. How do we add the number 22 to this array?
Brackets. Oh, var 22 equals bracket.
Nope. Allison, how do we add this a value to this array?
Add it to brackets.
I'm saying, say it again.
Add it to the brackets.
How do I do that? What do I type? Not sure. Okay.
But
Yeah, here.
put 1.0 inside the brackets on the right side of the first line.
Like this? Okay. That's exactly one way to do it. If I don't want to do it on that line, and I want to do it on the next
We
line,
can do,
how do I do it?
we can either do sum doubles dot append,
Sum doubles
dot append,
dot append, and then
brackets, 1.0.
oh, is it bracket?
Sorry, the,
Parens.
yes,
All right. And then another double. Yes.
Yeah.
So let's just do two.
The other way could be sum doubles and the first position in the array is 0. This time it would be brackets 0
Okay.
equals something.
Well, so 3 point. Like this.
Could you also do it var sum double equal bracket and then add the doubles in between the brackets?
Okay. So var.
So
Let's
var-
do some doubles.
Sum doubles.
Because we need a different variable.
Yeah,
Okay.
equals bracket 2.0 comma
And then
3.0.
Okay. That is absolutely correct. That's another way of doing it. This is implicitly typed. Since we've given it an array where every element that it has the same type. So then Swift automatically thinks that this is an array of doubles and will always be an array of doubles after that point. Yes.
So we just passively like sum doubles dot append and then instead of prime have sum doubles too, and then it appends two values.
Okay, say that again.
Could you do sum doubles dot append and then pass the variable name sum doubles too? Would it add those to the array or not?
Like this.
Yeah.
Nope.
No. Okay.
Probably not. Because why isn't this working? All right. Why wouldn't this work?
Append only accepts one element and not an array of elements. Is that correct?
That's right. And another way to say it would be that append, because sum doubles is an array of doubles, then append is going to expect a double. Right? So we can't actually do this. But the spirit is there. What we want is an array that has 3, 2, 2, 3 in it. Right? So Art, how would we do this? Sorry, I have to keep going around. How would we do that? How would we take these two arrays and combine them?
Oh, come on.
Yes. So you can see the intent here, right? But that's completely unacceptable as far as Swift tells us. So how would we take these two arrays and combine them together?
Use the plus sign.
Use the plus sign. Oh my gosh. Like this. Oh, so this is called concatenation. Concatenation. So this will not work, but this absolutely does. Okay. Fantastic.
I just have if you put sum doubles to bracket 0, then it wouldn't work, right? Because now you're referencing.
Indeed, because the type that comes out of this is what? A double. So we can actually put any double in here that we want. So we can even do this. Right? We can just keep adding doubles all day long. No matter what we put in there, it has to be a double. And no matter what process that we use to get to that double, it's perfectly acceptable there. There could be a function that is just, that all it does is return a double.
And right.
What is the constant 2.1, 2.87, or So this is why return values are so important for functions. It's because we know when we call the function, we'll get a double. So now we can use that as any other double. We can use it as if it were a constant. Anywhere a double is accepted, we can place that chunk of syntax there. Okay. So now we have this array, sum doubles. And it equals this crazy set of values over here. So using a for loop, how do I iterate over this array? So Ned, do you remember how to do this? Nope. Constantine, help me out. How do I iterate over this array with a for loop? For in, do you remember? Nope.
Here's a hint, guys. Open up your PDF. All the answers are in the PDF. Does everybody know where to find that PDF?
This is never closed book.
This is not a class about memory.
Even though I say, do you remember? I don't have it linked here. Sorry. I think I forgot to put that in. But we go into lessons 9. The PDF is right here.
All the answers are there.
And also the previous one in lesson 8, where it's actually in greater detail. But here's your cheat sheet. Right there. Okay. Partly what this exercise is the ability to go find the information. So if you understand what I'm talking about when I say, give me a for loop, iterate over this array, that's the part that's important.
This is lesson 8 or lesson 9?
Today is lesson 9. So this is the PDF for lesson 9. And I forgot to link it properly at the top, which I can do. But all you really have to do is click on the folder structure here, lessons, and then at the bottom, lesson 9. The PDF from lesson 8, however, is more extensive. It just has descriptions for every line in the sections about arrays and dictionaries. So depending on where you feel you are, if you feel like this is enough to jog your memory and to find the concept, great. If you want the previous PDF that has a little bit more verbiage and clarity to it, then you can use that one. It doesn't really matter. So anyway, again, the important part is the concept, not the syntax. So if you don't remember what the syntax is, you can always look it up. But what I'm really testing for is when I say, write me a for loop, or help me iterate over this array, that you know that, iterate, that means for loop, or that means while with accessing by index. So now, let me go find out how to do that, and see if I can project the problem into this syntax. So, let's try it. Let's try it again. Constantine.
So, for sum doubles,
Oh, is that right?
actually, we have to name the element
Aha.
inside.
Name the element.
For L, and then we
What is it? Tell me what to type.
EL.
Yeah. Okay, great. So the reason why I stopped you right there is that the variable L is a nomen.
Oh,
When you say L and you're meaning the letter L, never use the letter L as a variable name. Can anybody tell me why?
Here's one.
That's exactly right. So, terrible variable name. Other terrible variable name? Capital O. Bad. No.
0.
That's right. Depending on your font, you can sometimes tell the difference, but sometimes you can't. So, okay, for L.
Brackets.
Oh, brackets. Is this right? Look at your PDF. What does it say after that?
Oh,
In. All right. So now what are we iterating over? Sean, what are we iterating over?
Some doubles.
Some doubles. And now what do I type? Again.
Brace all plus equal L.
Okay.
No.
We don't really know what we're doing yet, but let's say we wanted to do something like sum them together.
Mhm.
So if I gave you this, and I say, give me the sum of all the elements in sum doubles, what would you write?
Sum
Yep.
equals 0?
0.
No?
I already have sum equals 0. Why would I want to?
Sum equals L?
Equals L.
No.
So then at the end, what do I get? I get L equals,
Is it plus or equals?
I'll fix this for us. Sorry,
Plus or equals?
it's just plus equals.
Okay.
So there's no or.
Yeah.
So again, very precise when we talk about syntax. Just exactly what characters you want me to type. All right. Unless there's a shorthand parlance that we have for it. But this is excellent. This is perfect. So we've iterated over this array, and now we have the sum of all the elements in the array. So let's move on to dictionaries, because these are really the array fundamentals. You have to know how to instantiate them. You have to know how to append elements to them. You have to know what it means to use other expressions that have the type of the element inside of an array with regards to dot append, how to concatenate them, and how to iterate over them. Okay, dictionaries. All right, let's go over this again. How do I declare, Raj, how do I declare a dictionary from string to double? How do I declare a dictionary whose keys are strings, whose values are doubles? PDF open?
Yeah.
So the dictionary page. It says string to double.
Where constant.
Okay, I've already given you a variable. So just tell me what I have to type after the variable declaration. Just pick one.
Wait, I don't understand the question.
Okay, so I have a variable, and I want to set the type of this variable. And I want that type to be a dictionary of string to double. So the keys are strings, and the values are doubles. How do I do that? Allison, do you know how to do that? From what the PDF said?
We could add a colon after string to doubles and then, brackets,
Okay,
and then string, colon, double.
like this. And then what else is there? Is that all I have?
And bracket.
Another bracket, but there's another piece of syntax that I'm missing, is there not?
Oh, she said it.
She said
She said it? Oh,
She said colon double.
excellent. Thank you. Sometimes sound doesn't always reach.
In this case, I can call.
Nope. In this case, it does not matter. But it's a worthy question because sometimes spaces can be a little tricky for us. So now I've set the type, I've declared the type of this variable as a dictionary from string to double. How do I initialize it?
Equals
Equals.
two brackets with colons.
Excellent. Okay, strings to doubles. How do I start adding key value pairs to this dictionary?
You say, in equals bracket, declare whatever string you're adding, so,
Okay, let's do pi.
yes,
That's easy.
oh, yeah,
What?
no, colon, sorry.
Excellent.
And it'll be 3.1415.
That works for us right now. So, what did I actually do here? Did I set a key value pair on that dictionary? Or did I create a whole new dictionary? All right. is telling me there's no such thing. Is the syntax there in the PDF?
Yeah.
Let's do a lookup together. So we say, oh look, add another key value pair right here. Do you see? It's right in the PDF. I say, how do I add a key value pair to the dictionary? Add another key value pair to the dictionary. Like, it's right there. So strings to doubles. Sean, how do I add a key value pair to this dictionary?
Dictionary, open bracket. You can still do pi, can you?
I'm sorry?
You can still just do pi, can you?
And just do pi. Do I do quotes or do I not do quotes?
You do quotes.
Okay. So we have to be very precise when we're talking about dictating code. You can either say quote pi quote, or you can say a string pi, just name the type, and then that assumes that the person that you're with knows how to write a string literally. Okay. What's going to start happening for the rest of the course is you're going to start coding together. So you have to learn how to communicate about what these things are. Like you can either say just type string, or you can say things like give me a string and put equal to hello. And so that person should know that means double quotes hello. Okay. So what's the rest of the syntax?
Just equals 3.14.
3.14. Excellent. So do you see the difference between these two pieces of syntax? This adds a key value pair to an existing dictionary. This creates a new dictionary. So this is a completely new dictionary literal, as we call it. You've typed out every value explicitly. Okay, so
Can I real quick?
sure.
So in line 46, if we actually were using that syntax, all the values that were in strings and two doubles before that would be false.
That's correct. So let's do this. There we go. Pi is gone. Right here. So it completely replaced everything. It's a brand new value. It has nothing to do with the old value that we had set up. So be very careful when you're working with dictionaries and arrays like this. When you start using literals. Typically what you want to be doing is you want to be using that variable and using methods and assignment syntax like this in order to manipulate the value that variable holds inside of it.
Do dictionaries have methods like add? I know we don't get remove, but is add in there?
I rarely ever use it if it's there, but I don't think I ever used it. There's index for keys, remove it index, value for key, just update value. So this is probably what you want. But I rarely ever use it. Have you ever used this?
But for update value, you would still have explicitly have to call the string.
It's just more type.
So there you go. Okay. So table views. Let's move on. So we're going to try to build up enough understanding that we can actually create a task management app today that uses some well-defined iOS patterns that, again, are common to many other iOS apps. So this is, in a way, trying to go meta a little bit. You've already created apps at the very, very beginning of the course. You've learned about Swift in 5 different lessons, everything from variables to data structures to classes. And now we're going to take all of that knowledge and put it into what we call well-established design patterns, which are arrangements of classes and objects to each other that enable you to describe in a very disciplined and very structured way different this case for table views. So one of the reasons why we're going over this is because table views themselves are quite inflexible when we use a table view controller, but they can be quite flexible when we adopt design patterns like delegate patterns. So one thing that you could not do in this app, for example, is add a toolbar to the bottom of this view. It'd be very difficult to do. So what we're going to teach you how to do is how do you deal with the table view by itself and mix it with other UI elements. So just as a quick review, table views are lists of objects, and they're organized in a two-tiered hierarchy. That first tier is what we call a section. So again, your contacts app on your iPhones, they have section dividers that are the first letter of a last name or the first letter of the first name that scroll with you as you're scrolling. And then a row is a single entry in that section. So what we have to do is we have to have a way of describing a single row. And iOS gives us this class, or it's a struct. Anyway, these objects called index paths that are a combination of two integers. One is a section and one is a row that describes, so we can actually use that to target any given row in a table view. This notion of a cell describes a UI view, which is the thing being drawn in the table itself. Does that make sense? So, table views themselves, if we're talking about so we're paying attention to this section now as opposed to this section up here. Table views have two objects that are applied, that work along with them to describe what goes in them and what happens when the environment around a table view changes. One is called a data source, which is the thing that provides the information to draw in the cell. And another is called a delegate, which has a set of methods that are called when particular events happen on these cells. So things like user selected a cell by tapping on it, something's being edited, something's being deleted, etc., and so on. So we're going to go over a lot about data source and a little bit about the delegate today, because the delegate can get pretty complicated. So let's skip this. So the dog catalog. I wanted to go over a little bit about what happens in the app, in the app that we tried to create at the end of last class. So the dog app itself. Looks like this. That's all that it was intended to do. Like, all you do is call up the modal dialog, type some text into the text view, hit add, and then that name that you typed shows up in the table view. So the question is what actually happened there in the code that we wrote? What actually happened was something like this. User taps add, and the modal dialog appears with some UI elements in it. Remember, that modal dialog has a particular view controller attached to it that we wrote, what we call the modal view controller. That thing contains references to two things: an IB outlet to reference the text view, and IB actions that are called when you tap done or tap dismiss. What happened is the user types data into that text field and taps done. And then what happens is the IB action that's associated with that button that says done is called. That's a function that does a series of steps to take that piece of raw data and turn it into data that our app can hold onto and display in the table view. So what it does is it grabs the string that the user typed out of that UI element, creates a new instance of the dog class using that string value as its name property. And then what we do is we have a reference to the previous view controller, the view controller that has the table in it, and we call a method on it, insert new object, like dot insert new object. And then that takes on the responsibility of taking that instance of a dog, adding it to its array that it's holding, its data store, essentially. It's a data structure after all. and then telling the table view to update itself with that new piece of data. This is a very common pattern. The next thing that we can do on top of that is to have another view to edit that dog, right? So we have a create action, we have a read action where we're looking at that in a table view. Later today we're going to do an update action, and eventually we'll do a delete action. You can get rid of a line out of the table view. It's called CRUD. There's a design pattern for you. Create, read, update, delete. Those are the general actions that you have to perform on any chunk of user data that you have, especially pattern user data, meaning I have a lot of entries of dogs, a lot of tasks, a lot of, or a collection of any single type of data. So we're going to repeat this today, but instead of dogs, we're going to use tasks. So the skills you're going to need to make this happen. 4 things we're going to go over very briefly now, and then I'm going to construct this entire app right before your eyes. And then you're going to construct the app. You're going to reconstruct the app together. So these 4 things: references, protocols, segues, and casting. These 4 things that we have to know how to do. References. We've done this before, but it's worth mentioning again. A reference is a notion that a class or an instance of a class can refer to an instance of another class. And when we talk about passing by reference or holding by reference, it means that everyone that refers to that instance sees the same instance. There's only one instance of Angel, one instance of Megan, one instance of Sean. And whenever one of them changes state, if they change their name, if they, file their taxes, whatever, everyone else knows, right? There's never a new Angel that's created in that sense. So in this case, what we're doing is, in the example that we had a couple weeks ago, is we have 2 classes, a dog and a person, and then a dog can hold a reference to a person with its owner. So we can do this conversely as well. Now that you have data structures, you can create a person that holds an array of references to several dogs that that person may own. You understand? So a dog typically only has one owner. Even when you believe that you're a dog's owner, the dog may own you. But nevertheless, this is how this concept works. And what I want to do is quickly go to a playground and show you what that means. So you don't have to type this out. In fact, I recommend that you don't. Just watch. So I'm going to recreate this dog class. And just watch how fluidly I'm doing this, because this is the kind of typing that you're going to end up doing yourselves. I'm not typing anything here that you haven't seen before. So I have an optional person. I'm actually going to do it this way, because we're going to use this syntax from here on out with UI views. This is what's called an implicitly unwrapped optional. It means that you don't have to worry about using that if-let syntax, but it does mean that you have to worry about setting that value immediately when you instantiate an object that starts to reference this. So let me show you what that means. So I'm going to create a class person, who also has a name. It also has an initializer that takes a type string. And all it does is remember that name using this property. And so I'm going to create a single person. So this is my sister Ellen. And her dog, Layla. I've created this dog, and I'm going to give this dog an owner. Like this.
Where's the EM come from?
I just made it up. I could call it a person if I want. Remember, variables are just my way of being able to describe a piece of information in the app. So Swift doesn't care what that is. It leaves it entirely up to my choice. So it's my responsibility to choose something that's readable and that makes sense variables like x typically don't help us. But a variable like my sister definitely helps us, right? So, in any case, now I can always say dog.owner. This is a reference to Emily. So if I have another variable, dog2, also terrible, terrible variable name, so I apologize. This dog can also have the same owner, my sister. So if I were to reference those owners' names, those should both be Emily. If I change Emily's name, and I just copy that same exact code, both of them update. This is what we call by holding by reference, or holding a reference to an instance of an object. So that way, whenever values from them change, these dogs are aware that those values have changed, that those properties have changed. Something very, very important to understand this concept when we're talking about creating really complex apps. Because every view controller is an island unto itself. Every view controller is a class, so it sees only its own properties when iOS instantiates that class for us. When a new scene comes into view, we are writing instructions that tell iOS, create an instance of this class with these properties and these methods. And that's new every time. So we have to be responsible for performing this operation on line 77 and the operation on line 71. Passing those references around so everybody knows who they have to be talking to get all the information that they need to finish whatever it is that they're intended to do. Does that make sense? So for example, the add new task view that we're going to have to create has to know about the view controller that holds all the tasks. The view controller that holds all the tasks has to hold them because it has to show them all to you. Right? Okay.
Go ahead, sorry, could you go back real quick?
Sure.
What you were going to make, or maybe you already did make the point, the person, the unwrap implicit?
Yes. So I'm setting it immediately right here. So I do dog.owner in this case. I get nil.
Oh, I see.
So nil is always a tricky value because you have to always test for it. So these implicitly unwrapped optionals come up a lot in user interface code. So IB outlets, for example, all implicitly unwrapped. So we don't have to explicitly unwrap them by using that exclamation later, but we'd have to be really responsible about ensuring that those are not nil, because nil just fucks everything up, quite frankly. If the nil value gets in there into a chunk of code, it doesn't expect it. So IB outlets, for example, we always want to connect them to something real in an interface, and that initializes it, like the app framework will initialize that property for us when we run the app. Make sense? Okay. Next concept, protocols. Protocols look like classes, but they're not classes. A protocol is a group of methods that another class, a consumer, expects a class to have. So if we say that a view controller meets a protocol, it means that all of the methods that show up in that protocol are being used by that view controller. So it's a contract between two objects, so that if one object says, I meet this protocol, the other object can be assured that the object that meets the protocol has all of those methods available that are defined in the protocol. Does that make sense? So that contract means that whatever is consuming your object, that guy that's consuming can call those methods on your class, and it is assured that they are there. So this happens a lot because there's a chunk of code that Apple provides us and a chunk of And there are two ways, and the contract goes both ways. Meaning that I know what methods I can call on those objects that Apple provides me, and I have to be able to express to the app framework what methods I'm providing that it expects to see. So in the syntax down here, you see that this first identifier that shows up after the colon is your superclass, just like when we extended dog to be a sheep. We can also add protocols. So all this does is say that whatever methods show up here should also be here. I should override them here. Just
And what's like the syntax inside that, the braces? Is it like
same exact, looks exactly the same as a class. So I'm going to write func, and I'm going to write
yeah,
the type signature, but I'm not going to put anything in the body, typically, unless it provides default values. These methods that show up in the protocol can be optional or required. So the required ones are the ones that I'm talking about, but there are optional ones as well that more intelligent consumers will be able to distinguish between. Okay, in our case, we're interested in two protocols. We're interested in this UI table view data source. Names are going to start getting really long, by the way. So this is telling our view controllers that they're going to provide a set of methods that give data to the table view. The UI table view delegate is a protocol that has a bunch of predefined methods that describe event handling, when things are selected, when things are deleted, etc., and so on. So it'll become more concrete when I actually start showing you the example. Segues, you know what segues are, you've created them. You've created these transitions, essentially, these animated transitions between one view controller and another. The thing that we haven't really talked about explicitly yet is the fact that these are actually objects of a particular class. And we can get those objects and manipulate them just like any other class object, just like any other instance, rather. And that instance has data, has properties that are super important to that passageway, that transition between one view controller and another. Because it's the only thing that knows where it's coming from, where it's going to. So it holds references to both view controllers at the moment when that transition is about to happen, right? So we can actually grab data from one and stick it into the other if we need to. Super important because, again, view controllers are islands unto themselves. And then it'll, again, become more concrete when I actually show you what's going on, how to do it. Casting. This is the last concept that you're going to start to see. You've seen it before. It's this funky as keyword. But I want to explain a little bit why this process exists. Casting is the process of telling Swift that you want to take an instance of one class and treat it as if it were, of one class and treat it as if it were an instance of another class. Make sense? So typically we can call methods on a given object, dot whatever, and by default, in our understanding, we could go to that class definition and see everything that we could say dot for. But because of inheritance, because of the fact that we can extend classes, sometimes it makes more sense to treat types as the more generic kind. So as you go up that hierarchy tree, meaning you go from superclass to superclass to superclass to superclass, remember we had like animal, and then we could extend animal to be dog, and we could extend dog to be Shiba, and we could extend Shiba to be red Shiba, and it gets more and more specific as we go. There will be many situations in which we want to describe code using that more generic class hierarchy, the more generic classes. So Apple does this a lot. Apple can never possibly know the classes that we're going to create in our own apps. So a lot of the code is written in a generic way. So for example, you'll get a lot of code that just says, I expect this to be a UI view controller. But what you have is a view controller that you defined, like new dog view controller, right? But if you just had a view controller, you wouldn't have all those methods available to you that you wrote in new dog view controller, right? Like dot create new dog and all of the references to text fields and whatnot. So this technique right here enables us to say, give me that generic thing, Apple. Now I'm going to pretend as if it were my thing. I'm going to pretend as if it were a new dog view controller. And then after that point, you can do all the dot accessing that you want to do on an object that you define, on a class that you define. This can be very dangerous because if you have, let's say, you had a method that was dog, and you know it's a red Shiba, and you say as red Shiba, but instead of a dog, you got a tiger, game over. Like that, this will complain at runtime. Like meaning while the app is running, you tried to cast a class to some class that wasn't part of its inheritance hierarchy. Like it had nothing to do with the class that you had gotten. And so that can be disastrous to an app. So we have to be very careful in using this technique. But it's very necessary, especially when dealing with view controllers, and especially when dealing with table view cells. Again, examples in the future will make this clearer. A to-do app. All right. Here we go. What I would like you to do is not follow along with this code. What I want you to do is take notes on what I'm doing, but in plain English for yourselves. But I want you to preference watching me over writing the notes. So if you feel like you're falling behind because you can't type your notes fast enough, I want you to skip it, stop, and just watch. Because you're going to repeat this exercise together. So the theory being that partially incomplete notes from two students is going to yield better understanding than complete notes where you missed stuff because you missed a concept when I was going over it. Okay? So we're going to go one step at a time. We're going to go from the ground up. So this is going to be crazy. This is going to be crazy exciting. This is what we're going to try to achieve. I'll put this up later as well when you try to do this yourselves. But all we're really going to try to do is first, stage one. Create a table view that has some text in it of tasks that I want to do. Buy an Apple Watch, purchase Apple Care, sell my iPad. All appropriately Apple related. What I'm going to show you how to do is to add that table view into the view controller. And then how to start defining that view controller given these two things that we talked about, these two protocols. I'm going to show you how Xcode makes it convenient for you to actually write these. So that's stage one. Stage two, we're going to get that button working, adding a new element to the app, adding a new task to the app, right? Stage three, which is going to be the end of class on your own with my Angel's help, is we're going to enable you to edit a given task. So swiping over to the left and revealing what we call the accessory view. It's okay if we don't get there, because it's in principle the same thing that's going on when you hit add. Okay? So it'll be okay. The goal is just to have you get facile with creating all of this stuff yourselves. Alright. Here I go.
It's a single view application.
Just a single view application. Some of the other templates are convenience templates. If you're trying to create an app in an afternoon for some crazy reason, like you can use some of those templates, but a single view application is generally the best place to start. If you're not sure. Okay, so oops, sorry. Look at my notes here just so that I do this the right way. Okay, so I'm going to go to the main storyboard, and we're going to do the standard procedure where I'm going to disable auto layout. I'm going to search for table view. I'm going to add a table view to this layout. Oop, I can't do that like that. Just add a table view to the layout.
What's that called? Like the list of, yeah.
The library. Okay. So now there's a couple of things that I have to do to configure this table view to work. I have to go to its properties and tell it that I want to create what we call prototype cells. These cells describe how information is going to be laid out in each cell. And it comes with some defaults, but I have to take prototype cells and I have to change this number to something that's not 0.
Oh, wait, what is that called? Where you just went?
Okay. So it says table view. So this is the library.
Yeah.
This is the inspector. This is interface builder that we're in. There's the debug panel down below, and then the document tree on the left. You just create the terminology for yourself so you can remember where things are. So this inspector here we call attributes inspector. And then under table view prototype cells, change it to 1. And you'll notice that a blank cell pops up over here. What I'm going to do is select that cell, and now I get properties for the table view cell. The thing that I want to set is this field here called identifier. This is going to allow me to set a value, which is a string, that I can use to refer to this prototype in the code that I'm going to write. Okay? This functionality enables you to start defining your own custom cells later. So, but what I want to do now is give it an identifier that makes sense, task cell. Then I'm going to change it to basic. I'm going to change its style to basic. What basic does is it gives me a single, you can see here, a single label, UI label, that I can set a value on. I can actually start to write text into that table cell. Okay, great. So now I'm going to go to the code that represents this view controller, which is right here, view controller. I'm going to create a reference to this view, that table view. But I'm going to type it manually, like this. I can also drag over from Interface Builder, but this is also something that you can copy and paste from a different project. Don't worry about exactly what the code is, because this will make this available to you later or over Slack. So, but the thing that I'm going to show you here is a different technique how to link these things and how to link code with UI elements. But the thing that I'm trying to achieve is to ensure that I can refer to this table view not using a property in my code. So I'm going to go back to the storyboard. I'm going to right-click on my table view. And I'm going to connect 3 things. The first thing that I'm going to connect is new referencing outlet to this little yellow dot here. That little yellow dot represents my view controller. And you'll see that the IB outlet that I just wrote pops up there, table view. I click on that. Now I've just created that referencing outlet. What you'll notice the table view has these two additional outlets here, data source and delegate. That gives me the opportunity to tell the app who is going to be my delegate object. Just like the dog had an owner, the table view will have a delegate, which is another instance of another class that retains the responsibility of dealing with all of the table view's events. Make sense? Just like a dog has an owner, and the owner is responsible for dealing with all the dog's events, like pooping. No? Okay. The table view has a delegate that deals with events on the table. What I want to do is also connect that to my view controller like this. So just drag it up to the yellow dot. Same thing with data source. Dog has an owner. Table view has a data source. And that data source is responsible for determining what the cells are, the contents of all the cells that it's going to draw. So again, I'm going to drag that up to this little yellow dot and let go. And that's it. And then save, because I'm a compulsive saver. Alright. The fact that I linked this instance, this class rather, to that table view, means that I'm now responsible for meeting those two protocols, the UI table view delegate and the UI table view data source. So in order to tell Swift that that's what I want to do, that that's what I intend to do, I'm going to add a comma-separated list after my superclass for those protocols. So one way that I can ensure that I type this correctly, because the names are really long, is to start to use the autocomplete feature in Xcode. So if I hit escape, it's going to give me those two protocols because they're available in my scope. They're made available through that line number 9, import UI kit. So now when I hit escape, I can just pick them.
That import UI kit's like whatever you put on the main storyboard, that's what it imports basically. So you can like add on to the code from there. Is that the thought?
The storyboard and this
Like the
code are
interface.
separate.
Okay.
Yeah, but the storyboard definitely knows UI kit because it's responsible for rendering all the different kinds of UI elements, but that happens automatically behind the scenes.
Mm-hmm.
So import UI kit here is solely responsible for this file that we're in.
Mm-hmm.
Does that make sense?
Yeah, but I guess the interface I thought like reflects this code. So
It does.
because you just
Because
link
I
those up on that other screen.
That's right. But it doesn't really have anything to do with line number 9. They just both happen to import UI
Okay.
kit, and one is implicit and one is explicit.
Got it.
Does that make sense?
Yeah.
Okay. Excellent. So the delegate methods we're going to ignore. We're just going to focus on some of the table view data source methods. First thing I have to do here is to actually create a property that contains the tasks that I want to achieve. So I'm going to paste in a little convenience line that I have here. It adds a property called tasks, like this. Var tasks equals blah, 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 blah. What type is this? Really? What's the full type of tasks? Maybe you know it.
Array.
Array of strings. Array of strings. That's right. Okay. Just making sure that's all. Making sure it's all together. Okay. So now what I have to do is teach this view controller how to populate my table view. Okay. So the way that I'm going to do that, and I really wish I had more scroll space down here, you guys. All right. So I'm going to create a little comment called a mark. And I'm going to label it table view methods. All that does is create a little marker in this drop-down menu up here. But it's always good to comment your code so that you can remind yourself where methods exist. This is entirely up to you, but I recommend this technique because it makes this view up here much more useful. What I'm going to do is start to add a few methods that govern how this table view behaves. So there are 4 that I'm going to add. 3 are super simple, and 1 is really complicated. So I'm going to go over the simple ones first. First one is I have to tell the table view how many sections I have. Remember, table views are divided into sections, and sections are divided into rows. So I have to tell it how many sections. So the way I'm going to do that is to start to type in number and hit escape. This method comes out of the data source protocol because I've imported that data source protocol into my class. Now I can autocomplete and start to write these methods in a very fast and rapid fashion.
So you just start writing a number
And I hit escape.
and you hit escape.
That's right.
So whatever you type and then you hit escape, it will provide you if there is some options.
Exactly right.
Just keep in mind that the reason why that shows up is because he has that as a data source. So that particular method is part of the data source delegate. And that's why it shows up.
Yeah, because I have these guys. Now Xcode knows when I hit escape to search everything in here, everything in here, everything in here, everything in here. Does that make sense? Okay. So now I have this guy in code. I only have 1 section because I'm only going to deal with tasks. So I'm going to say, I'm going to return what type? Int. So I only have 1 section, so just return 1. And I'm done. 1 section. Next one. If I start typing table view, this is where things get a little bit obtuse. Because of the relationship between Swift and Objective-C, there are a ton of methods that begin with table view, but their syntax is a little bit funky. It looks like this. The name of the method that we want, we're actually looking right here. Okay? This long ass stuff right here. Perform action, number of rows and sections, etc. The one that we want, we're actually conveniently sitting on. Number of rows in section. So we have to tell the table view how many rows do you have in this section. Hit enter. The number of rows that I have in the section depends on how many tasks I have. Yes, I could return 3, or in a more general way, I could say self.tasks.count. So therefore, whenever my number of tasks updates, this will also update. Can edit row and index path, is that required?
No.
It's not required.
No. If you don't add it, then when you click, doesn't do
It
anything.
doesn't do anything. Alright, then we'll skip that. Alright, so there are only 3 that we're going to show instead of 4. The other one is this one here. Cell for row at index path. We actually have to produce an instance of UI table cell, because as we're scrolling, what it's going to do is start to create these instances of cells, but also recycle them. So it's going to use the minimum memory footprint as possible as we're scrolling. There's no real reason why you would not do this. So we're going to just show you how to do it. Unless you had a well-defined set of cells that you were using that never ever changed length or something like that. But generally this is the pattern we're going to use. So we get this method. Okay. Remember when we set that identifier before? Task cell? This is where we're going to deploy it. We have to do a number of things here. We actually have to grab an instance of a table cell that the table is providing for us. And then we have to get the corollary task and then set a label on that cell to reflect the value of our task, the title of our task. So step 1, get the cell. Let cell equals PQ reusable cell with identifier. It's a mouthful. We want the one that has 4 index path in it, because we're actually given an index path. Remember, an index path is just a section in a row, so that we can spot a particular row. Hit enter, and I need 2 arguments. I need an identifier for that cell, which we set in interface builder earlier as task cell. And then an index path. Luckily, this method comes with an index path as an argument. So when Xcode, when the app framework is calling this method, it's going to hand us the index path of the row that it's trying to draw. So all we have to do is type index path. The name of that argument is index path. So now I have a cell. Oh, there's one missing piece. I have to cast this. It's going to come out as an any object. So what I have to do is cast it as a UI table view cell instance. You'll see that I'm using an exclamation mark here. That's because I'm on the latest version of Swift, which I think is now official, if I'm not mistaken. I think it's out of beta.
What version are you on?
I'm on 1.2.
There's an update today.
There was an update.
But I don't think that, I think it's still there.
It's still there. Okay, in any case, what that means is you might not need the exclamation mark there, but Xcode will tell you, so don't worry. Okay, so I have an index path object, which actually was at a section in a row. We only have one section, so I don't have to worry about what that is. But what I want to do is get a reference to the task that I'm talking about. So I'm going to say let task equals, and what that means is that I'm going to reference my array that I've written, but I'm going to use the index path that's being handed to me. Do dot row on it. Index path always has dot section and dot row. That's pretty much all that you can do with it and all that you'll probably ever do with it. Now I have to tell the text, the UI table view cell that I have a piece of text and I'm going to set the UI label in that cell to my task. That's what I want to draw. Cell dot, yeah. Text label. I'm going to hit escape here just because I want to show you something. The text label this text label property is optional, right? So I have to unwrap it. I unwrap it with an exclamation mark. So the syntax is going to look a little bit funny, but since I trust the basic prototype that comes along with that code, that's basic prototype, I'm going to assume that it's never going to be nil. Now I'm going to do dot text. Remember using UI labels before? There's this property text, which is what am I drawing inside of me. I'm going to set that to task. I can set it directly to task because I know that this accepts a string, an optional string, so I can set it to nil or a string. I know that task is a string because I made it an array of strings, and I'm indexing into it, so I'm getting a string out of it. String, string, string. String, 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 string. Right? String. Types have to match in Swift. Now, I return the cell. Why do I have to return the cell? Anybody have a clue? Constantine, why do I have to return the cell? Megan, why do I have to return the cell?
Because you want whatever you enter to appear on the other screen.
That's right. That's pretty much it. In Swift parlance, I'm defining a method that must return a UI table.